Hi and hello everyone. In the last module, we discussed how to write algorithms for a few computational problems. This module explores Raptor, a flowcharting tool. Welcome to the module on Raptor. Before introducing Raptor to you and trying examples with flowcharts, shall we have a look on something called logic? It is necessary to state the logic for the problem to be solved in terms of flowchart, algorithm or pseudocode. What do you mean really by logic? The logic should describe the sequence of execution of the statements and procedures needed for solving the problems using computer. The order of execution of the statements depends on some conditions and decisions. The logic can be described using one or more combination of the structures, namely sequencing, selection and repetition or looping. Already in the previous module on flowcharts, we saw an example for each of these structures. Let us revisit these structures briefly. What is sequencing structure? Most simple algorithms found in our everyday life are short and involve doing a series of things one after another. Normally the activities are done one after another. For example, in the coffee making process, we have to follow the instruction in sequence to get the desired result. Next comes selection structure. Sequencing is not the only way instructions can be ordered. Sometimes we need to alter the sequence of instructions depending on the condition. For example, in the coffee making process with choice, we have to skip the step add milk if the choice is coffee without milk. Finally, we have repetition, otherwise called looping. At times, we need to repeat certain activities till certain condition is true. For example, suppose you are asked to prepare coffee with enough sweetness, we need to repeat the steps, taste coffee and add sugar till the coffee with enough sweetness is prepared. Okay? Now, we are going to see how can we implement these three structures using the flowcharting tool Raptor. Raptor is a flowcharting tool created by United States Air Force for the use of academic community as just freely downloadable, and we are going to use this tool in this module for creating flowcharts for a few set of problems. You may be wondering what Raptor actually stands for. It is Rapid Algorithmic Prototyping Tool for Ordered Reasoning. Let me give a brief outline of Raptor. It is visual programming tool based on flowcharts. Raptor is a problem solving tool that enables the user to generate executable flowcharts. It is simple to use. Raptor was developed for the learners like you, being new to the computing discipline, for developing logical thinking and problem solving skills. You can download the recent version of Raptor from https://raptor.martincarleslie.com. You can see the link over the screen. After downloading, when you install the tool, it gives you an environment that looks like what is shown now. We will go through a set of examples shortly. Let us now see the basic features of Raptor. The working environment of Raptor is divided into 4 regions, that is windows. The one on the top is the toolbar. A symbol palette is located on the left side. Below that we have a watch window. The workspace at the center is the place where we create our flowcharts. Now we are watching these 4 regions of the Raptor on the screen. Over the toolbar, we can see the name of the Raptor file which has .rap extension. In the figure shown, as we have not opened any files, the file name is not shown. The symbol window shows the set of flowchart symbols supported by Raptor with little bit difference in notations. That is okay. When we draw flowcharts, you will get it. In order to draw a flowchart, just drag the symbols from the symbol window and drop on the workspace. By default, the workspace has start and stop symbols. So, you are required to insert the symbols in between them. In order to edit a symbol, just right click on the symbol and choose edit. A window gets open. According to the type of the symbols, certain fields need to be entered. Let us discuss them now. To start with, let us consider sequential structure. Take a problem of finding sum of 3 numbers. For this problem, first identify the inputs which are the 3 numbers to be added. Then, what is the process to be done on these 3 numbers? Nothing but adding them. Finally, we print the sum. Let us now do these steps on Raptor. When you open Raptor tool, the first thing you can see on the workspace is the start and start symbols. Now, we need to read 3 numbers as inputs. So, we need to add input symbol to the flowchart. This can be done by dragging the input symbol from the symbol palette onto the workspace. Now, place the dragged symbol after the start symbol. Now, either right click on the input symbol and select edit or double click on the symbol. Now, you can see a dialog box named enter the input. Each symbol in Raptor is associated with the dialog box similar to what you can see on the Raptor now. The first item what you can see in the input symbol is the prompt. Prompt is the one what you can see when you run a flowchart. So, the prompt needs to be given within double quotes. For our example, we need to give 3 numbers as input. Let us enter them one by one. So, we give the prompt as enter number 1 within double quotes, and the input symbol requires a variable to store the value given by the user as input. Already we gave an introduction to the variable in the module on flowcharts. Now, let us give the variable name as number 1. You may see this on the screen, then press done. This problem requires 2 more inputs. So, repeat the steps of adding symbols, prompts and variables for 2 more inputs as shown now. After placing the 3 input symbols, let us now insert an assignment symbol for adding the numbers which we have just now given as inputs. Insert either by dragging and dropping or select and click at the place where you want to put the assignment symbol. After inserting the symbol, double click on it to open the dialog box where you can edit. First, enter a variable name to hold the result of calculation in the field named set. So, let us give the name as sum. Then move to field and type the expression that calculates the sum of the 3 numbers. In our case, let us type as number 1 plus number 2 plus number 3. You may see these things on the screen now. And now press done. You can also use autocomplete facility to choose the variable names. After completing the calculation, we have to display the result. So, to do so, now insert the output symbol and double click on it. This will open an output dialog box. This dialog box has only one entry to be filled in, that is the result to be displayed. The text to be displayed for showing the results need to be typed as we want in double quotes, like within double quotes sum of 3 numbers is, and to display the results we need to give the variable which has the result. In our case it is sum. So, give as shown now, sum of 3 variable numbers within double quotes plus sum, and then press done. The flowchart is now complete and ready for execution. To execute the flowchart, follow as shown now. Click on the run menu in menu bar. A submenu is displayed. In this submenu, you may find an option execute to completion and click on it. The flowchart begins to execute. First, start symbol gets executed. The symbol being currently executed will be encircled in green as you are seeing now. Then next, the input symbol for reading the number 1 gets executed. When this executed, you are expected to give the first number to be added. You may watch on the screen for this. Now give the first number. Continue the execution of flowchart. You will be asked to give second and third numbers as you did for the first number. After reading the 3 inputs, the assignment symbol for adding the 3 numbers is executed and then the output symbol gets executed. Now, the result is displayed over a master console window. So, you are now seeing this over the screen. As and when the flowchart gets executed, you can see on the watch window to notice the values of the variable used in the flowchart. This feature helps you debug the flowchart for any errors. Raptor also lets you to execute the flowchart step by step. You can do so by choosing step option in run menu item. This feature helps you to trace the flowchart step by step and find any errors. So, the last thing you can do in this flowchart is adding comments. You can add a comment by right clicking on a symbol and choose comment, and enter command dialog gets open wherein you can type the comments. The comments are not executed but provide useful information about the flowchart. Adding comments will improve the understanding of the flowchart better. What you are seeing now is the command added to the flowchart just now we ran. That is it. Hope you have understood how to use Raptor for drawing and executing flowchart. So, it is time to start developing flowcharts by yourself. Okay. Now, let us learn how to draw flowchart for selection structure using Raptor. Selection is used to determine which particular steps are to be executed, that is, it allows us to take decision in our algorithm or flowchart or program. A selection statement can be used to take one of the 2 alternative paths depending on a condition. Consider an example of finding maximum of 2 numbers, say A and B. We need to compare these 2 numbers to find the maximum among them. To compare, we need to use the decision box. In our previous module, we have discussed how to use the decision box. Let us now learn how to use it to develop a flowchart to find the maximum of 2 numbers. First of all, do the usual things like opening a new file, adding the input symbol for getting the inputs, etc. After that, we want to place a condition to check the maximum among the 2 input numbers. For this, we need to add the selection symbol as you notice on the screen. As you can see, the selection symbol has 2 branches, namely yes and no. If the condition inside the decision box evaluates to true, then the left branch is executed, otherwise the right branch is executed. For the example we took, let us see how to put the condition. To put the condition, either double click on it or right click and select edit, and enter selection condition dialog box gets open. Watch this now. Now you give the condition to be checked as shown now, then click on done. Now you can see the condition inside the decision box which you have added as you notice now. When the condition evaluates to true, that is yes, we move to the left branch where we want to say number 1 is bigger than number 2. If you move to the right branch, that is when the condition becomes false, we need to say number 2 is bigger than number 1. So, add the output symbol as you are observing on the screen now. Now run the flowchart and see what is happening. Now let us take a real example for again illustrating the use of decision box. Given the height and weight of a person, assume that we want to find whether a person is obese or not. Use the table shown now to determine body mass index, that is BMI, and decide obese or not. BMI is calculated as shown on the screen. BMI is equal to weight in kilograms divided by height square in meter square. The flowchart for this problem can be drawn as you are seeing on the screen. Run the flowchart and see the output. So, the selection box is used when we want to execute different set of statements based on certain condition. Okay, fine. Let us move on to third structure called repetition. What is a repetitive structure? The sequential and selection structures what we have discussed so far have one thing in common, that is they got executed only once. It is very rare that a program will execute something only one time. That is why we have what we call repetition control structure. Repetition allows a set of statements to be executed any number of times depending on some condition being met. An occurrence of repetition is usually known as loop. While programming, we generally will use two types of repetition control structures, namely counting and conditional. A loop is considered to be conditional loop if it decides the number of iterations based on condition. Can you guess a real world example for this type of repetition? Think over here. In coffee preparation, we deploy repetition. Yes, if sugar in the coffee is not enough, you add sugar again and taste it. If added sugar is not enough, then you add it again. Here comes repetition. Next comes counting based loops. A loop is said to be counting loop if executes a number of times rather than on a condition. For example, when you upload photos, you would tag them. When you are doing, there is a iterating over a collection of photos and doing something on each of them. So, here you know the number of photos to be tagged. So, in both types, please do remember that the loop should have a termination condition to stop the repetition, otherwise the loop never terminates. This is known as infinite loop and is undesirable. Now, let us solve a problem using loops. Here is the problem of adding n numbers. Shall we see how to develop a flowchart involving a looping structure using Raptor? Here we want to keep the running total of n elements input by the user. For this problem, first we need to take the total number of elements to be added, say n as input, and for n times we need to take the actual number to be added one by one and keep the running sum as and when we give the number. That is, we need to repeat the process of reading a number, updating the sum with a number read for n times. As you think now, here we face repetition. As I have just now said, the repetition needs to be stopped at some point of time. That is, we should have a control over the number of times the repetition occurs. Fine. Now we will move on to Raptor for exercising the repetition. As you did for selection, do the usual things as you are noticing on the screen. Here, notice that the variable sum is initialized to 0. Why? Can you understand? Because when declaring or using a variable, the operating system reserves a chunk of memory somewhere which could have a random garbage value. When we use such variables, the initial values could affect the result of execution. In order to avoid them, we initialize variables. In our example, the variable sum is going to hold the running total of the user inputs. So, that is, whenever the user enters a number, it gets added with previous sum. So, when the user gives the first number, it should be added to the previous sum. Since this is the first number, the previous sum should be 0. That is why we initialize it to 0. Before continuing further, let me briefly introduce how to use loop symbol in Raptor. The loop symbol looks what you see on the screen. One ellipse and one decision symbol is used to represent a loop in Raptor. The number of times that the loop is executed is controlled by the decision expression that is entered into the decision symbol. During execution, if the decision expression evaluates to no, then the no branch is taken, which always leads back to the loop statement and repetition. The statements to be repeated can be placed above or below the decision box. Let me clearly explain how a loop statement works. Now look into looping structure on the screen. In this case, statement 1 is executed only once before the loop begins. The statement 2 will be executed at least once because it comes before the decision statement. If the decision expression evaluates to yes, then the loop terminates and the control is passed to statement 4. If the decision expression evaluates to no, then control passes to the statement 3 and the statement 3 is executed next. Then control is returned back to the loop statement which restarts the loop. Note that statement 2 is guaranteed to execute at least once and statement 3 may or may not be executed. In the example just saw, statement 2 could be removed, which means that the first statement in the loop would be the decision statement, or statement 2 could be a block of multiple statements. In either case, the loop executes in the same way. Similarly, statement 3 could be deleted or be replaced by multiple statements. In addition, any of the statements above or below the decision statement could be another looping statement. If a loop statement occurs inside a loop, we call this nested loops. So, it is possible that decision statement never evaluates to yes. In such a case, you have an infinite loop which will never stop repeating. If this ever happens, manually stop your program by selecting the stop icon in the toolbar. You should never write statements that create an infinite loop. Therefore, one or more of the statements in the loop must change one or more of the variables in the decision statement such that it will eventually evaluate to yes. Such variable is also said to be control variable as it controls the number of times the looping statements to be executed. Let us come back to our problem of finding sum of n numbers. See the complete flowchart for this problem. To find the running sum, we need to add a few statements. Two initialization statements before the loop starts. One sets the running sum variable to 0, which we have already discussed, and another variable count to 0. Increment the count by 1. A counter control loop typically increments the counter variable by 1 on each execution of the loop. A decision box to check whether the count has reached n. An input statement inside the loop that lets the user enter the number to be added. An assignment statement inside the loop that adds each individual value to the running sum variable. The variable name sum is not magic. Any variable name could be used such as total, etc. As long as the condition fails, the looping statements are executed. Here, when the count is not greater than n, we repeat the looping statements. Once the count becomes greater than n, the result of running sum is printed. As we here know how many times the looping statement to be executed, we use counting controlled loop. So, in this example, the counter variable is called count. You can use any variable name, but try to make it more meaningful and self-intuitive. The counter variable must be initialized to its starting value before the loop begins. Here we initialize it to 0. To recapitulate, in this module we have covered how to write sequential, selection and looping statements in Raptor. Sequential statements involve the execution of statements one after another without skipping and repetition. Selection statements are used when you need to execute some statements while skipping the others. Looping statements are used to repeat a block of statements. Thanks for watching the module on Raptor. Have a good day. See you all soon in the next module. Thank you.